Hello everyone, today I will be explaining a CCNA lab question to you. Let's look at the first question. So for this question, there's a section above with quite a bit of content. Basically, it tells us to configure the 4 switches shown in this diagram according to the task list below. The links between the switches. Make sure that this specific VLAN, which is VLAN 56, is set up. 77 and 99 as well. These 3 VLANs should be able to communicate normally. They should be able to transmit data properly. Now let's look at these 4 tasks. The first task says, configure these 2 switches, SW1 and SW2, specifically their E0-1 and E0-2 interfaces. Both interfaces should allow this specific VLAN. In other words, allow these 3 VLANs. For example, let's take SW1 as an example. Its configuration for the E10-1 and 0-2 interfaces should both allow these 3 VLANs, right? 50, 77, and 99. SW2 should be configured the same way. These are trunk links. And this part here is also a trunk. These 2 interfaces are configured the same way. Now for the second point, it requires that SW3 and SW4 are also configured as trunk ports, and they should also allow these VLANs. That is the 2 interfaces on SW3 and SW4. The only difference is the trunk below, which is called an EtherChannel link. Right? It's an aggregated link. Now we know that in Cisco's view, all the connections between switches are trunk links, right? The 3 links above are straightforward. Just follow requirements 1 and 2 and allow these 3 VLANs. Now let's look at the third task. The third task asks us to work on the E0-1 interfaces of SW1 and SW2, specifically the E0-1 interface. But on the E0-1 interface, in this case, when sending and receiving data on VLAN 99, no tagging is done, meaning the traffic transmitted between them is untagged without any tag. So how is the traffic transmitted? By default, this interface has a native VLAN, and the native VLAN is 1. On both sides, it's 1 by default because there's a default VLAN 1. Right? So at this point, your data comes in. Here, I've already allowed 56, 77, and 99. For example, if some data with VLAN 56 comes in, it carries the tag for 56. After it arrives here, let's take a look. The native VLAN, it's not the same. It's different from mine, right? Mine is 1, but the data here is tagged with 56, so it needs to check the allowed list. In this allowed list, 56 is allowed, right? Since 56 is indeed allowed, it can effectively carry this specific tag and then proceed to send it over. Now the crucial requirement is that when the incoming traffic, which is clearly marked with the tag 9999 actually arrives, it absolutely must not be tagged at all. So, in essence, do not write or apply the tag, and subsequently, it should be sent directly to the correct destination on the right. At this point, we need to change the local VLAN to 99. If we're going to change it, both sides need to be changed together. So this side is also set to 99. Then when the data comes over, it carries the tag 99 and sees that the local VLAN is also 99. So it will strip off this VLAN tag and send the frame as an untagged data frame, which is exactly what this configuration does. Right? On this E0-1 interface, you configure this setting, local VLAN 99. Right? At this point, it will do the same thing. It strips off the VLAN tag, and after sending the untagged frame over here, this device. Now, on the SW2 device, this interface sees that you are an untagged frame. Then it will tag you with its own local VLAN 99 and send it out. That's the concept. This is the third requirement, right? Both of these devices need to be configured. Both of them need to be set up for this, right? And then on their link, this also needs to be configured. Okay, and as for 3 and 4, as mentioned earlier, the requirement is for their 0-2 interfaces. You need to allow VLANs 5, 6, 7, 77, and 99, right? The 0 and 2 interfaces should allow these. Also, there's another configuration, which is for this port channel interface. This part hasn't been discussed yet. This part of the configuration is for this. First, we need to set up the port channel interface here, get the port channel interface up and running so that the port channel interfaces between them are configured as trunk ports. And also allow VLANs 5 and 56. 77 and 99 as well. right? That's the fourth requirement. For the fourth requirement, first we need to fix this interface, which means at the very beginning, we need to take these two interfaces, the two physical interfaces. We use the range command to configure these two interfaces together, configure both at the same time, and then add them to a channel group. Channel group 34, and set its mode to set the mode to active. Right, then both sides will automatically negotiate and establish this trunk link, and then we enter this port channel interface 34. That is, we enter this configuration means we enter this aggregated interface and then configure it to allow VLANs 5, 56, 77, and 99, and that's it, right? The configuration is the same on both devices. This is question number 808. This is a lab question. Right? This is a lab question. And for this lab question, after we finish the configuration, we must save it. Absolutely must. You must enter this command, otherwise you won't get any points. Right? After saving, then move on to the next day. And you see it's written here. You must save it. If you don't save, you won't get any points. If you just click on the next lab, then you won't get any points for this lab. All right, if anyone wants to get the question banks for all 4 subjects or wants to learn more about Cisco technologies, please leave a comment below the video to exchange technical knowledge.